a log is basically the opposite of a to the something. So log base a of something is the opposite of a to the power something. Alright? So if I know that 10 squared equals 100, that means that log base 10 of 100 equals 2. That is essentially what log is. Any questions so far? No questions so far? So when you're taking the log of something, if I'm taking log base 2 of 8, I'm asking the question, 2 to the what equals 8? Or essentially, we like to find x, 2 to the x equals 8. What is this? That's the question we're asking ourselves. Because we're basically undoing the power. Alright? So if I'm taking log base 2 of 8, I'm asking myself 2 to the what equals 8. This is a simple question because we know 2 to the what equals 8. What would that be? 3. 2 to the 3 equals 8. Therefore, log base 2 of 8 would be equal to 3. Alright? Are we okay so far? Alright, so if you're doing logs by hand, what you're going to want to do is you're going to want to set it up like this. Because what you would do is you would take 8 and you'd say 8 is 2 to the 3. And therefore, what you're looking for is 3. Ready for a harder example? Alright, so if I do log base 4 of 1 over 64. So the question we're asking ourselves before we make it too complicated, the question we're asking ourselves is 4 to the what equals 1 over 64? It could be. 4 times 4 is 16 times 4 is 64. So 1 over 64 is 4 to the negative 3. Therefore, log base 4 of 1 over 64 would be negative. Wait, I teach you this question? Alright. When I say 10 squared, well, there's no log involved in this. But if you want to write this as a log, basically the 10 is the base of the log. The 100 is what you'd be taking the log of. And 2 is what it would be equal to.
Yeah, it's like a cost, so it goes from
So it'd be log base 10 of 100 equals 2.
Yes, you go like this.
You draw like this. You go from the 10 to the 100.
So log base 10 of 100 equals 2.
It's always the same. It's
Alright, so while this way might help, I don't want you to remember a trick. I want you to know what log is. All right. So now I want to teach you how to do it basically my way, which kind of helps you more understand exactly what we're talking about with the logs. So if I want to express this as a logarithmic function, we already know what the answer looks like. It's going to be log base 10 of 100 equals 2. But this is why it's like that. The opposite of 10 to the 2 is log base 10 of that. Right? And so what you're going to do is you do the opposite of base 10, which is log base 10. But you're also going to do it on this side. So essentially you're going to have log base 10 on this side as well. So you're applying log base 10 to both sides.
Whatever you do on one side, you do this side.
Exactly. So that and that cancel each other out because they're opposites. And so you're left with a 2 equals log base 10 of 100. From a log form to exponential form. So what we're going to do is we're going to start off with log base 4 of 16 equals 2. So you know we started off with saying that log base 4 is the opposite of 4 to the something, right?
Yeah.
So if I want to put this in exponential form, all I have to do is do the opposite of this to get rid of the log. So the opposite of log base 4 is 4 to the power log base 4.
Oh, so.
And then what I do on this side, I also have to do on this side. So essentially log 4 to the power log base 4 of 16 is equal to 4 squared. Right?
Mm-hmm, yeah.
Now, in the topic we did right before this, the 4s were already there, and we took them away. So you know in math you can also go backwards. So
Yeah.
you can also put the 4s there, and it's still the same thing. The difference is, since these two things are opposite, they cancel each other out.
So the whole log is gone.
So the whole log is gone, and you get 16 equals 4 squared, which is the same expression, but in exponential form instead of in log form. Any questions? No? You want to try the next one?
Yeah.
All right. The next one looks, it looks harder, but it's the same thing. So essentially,
So we're gonna like about 5,
put a 5 there,
and then
5 to the this equals 5 to that.
then we cancel the log. So it'll be 0.2 equal to 1/5.
Yeah. We're just going to leave it at that because it said it wants it in the exponential form. So you just leave the exponent there. All right, so there's two things we need to know to do these problems. First thing, if I see a log of something and there is nothing in this spot right here, what's going to go into that spot is 10. Okay? Always. So it's kind of like when you see a square root with nothing in this spot, or I should say a radical. I give away the answer. Right, a radical with nothing in that spot has a little 2 here. Right? Or a number with nothing in this spot right here. There's a 1 up there, right? So we're just gonna have to get used to the fact that if I see log with nothing over there, that is a 10. Alright? And the other thing you need to know, the second thing, is if I see ln, that is a fancy way of saying log base e. So the same e that we use for continuous compounding, we use ln. What do you mean, Paul? lne. All right. So lne would be the same thing as getting log base e of e. Right?
Can you just put L and E in the
So you could put lne in the calculator, but I'll tell you what you're going to get. E to the what equals e.
E to the 1.
So they basically undo each other and just give you 1. If I'm doing log of 100, we said that whenever it's missing the base, there's a 10 there. So I'm asking the question, 10 to the what equals 100. Now we know that 100 is 10 squared, right? Therefore, log of 100 is 2. Right. So the next one is 0.0001. Log of 0.0001.
Yeah, see, no.
So how many decimal places is this?
1, 3, 4.
So this is just like saying log of 10 to the negative 4. Right?
Yes.
I don't know if you remember from scientific notation, you just count the hops to get to 1.
You know, it's easier to use engineering.
So essentially, this is log base 10 of 10 to the something, right? These two things are opposites. Just negative.